Hello students, good morning all of you. We have discussed up to question number 16 in our previous part. I have already uploaded part 1 and 2 and here I will discuss question number from 17 to last. Our 17 question is differentiate between efflorescent, deliquescent and hygroscopic substances with suitable examples. Efflorescent substances lose wholly or partially their water crystals when exposed to air and become powdery. Like washing soda on heating gives monohydrated sodium carbonate from decahydrated to monohydrated sodium carbonate. Next crystal when hydrated. Next one is the deliquescent substances. Deliquescent substances are those substances which absorb moisture, from atmosphere, absorb water, dissolve in it, forming a saturated solution. Deliquescence is maximized in dry conditions like KOH, NaOH, CaCl2, MgCl2, FeCl3. These are some examples which is used for absorbing moisture. They are crystalline, water soluble. For example, FeCl3 changes into FeCl3 solution. Hygroscopic means amorphous solids or liquids which absorb moisture from air of atmosphere and do not change their original state. For example, quicklime, concentrated H2SO4, phosphorus pentoxide, silica gel, etc. State do not change in these substances. They are used as a drying agent in laboratory. Next question is question number 8. Question number 8 is differentiate the functions of concentrated sulfuric acid as a drying agent and as a dehydrating agents. My dear students, sulfuric acid acts as a drying agent. Drying agent means for absorbing water from any substance as well as a dehydrating agent. Dehydrating agents means removal of water. It is fused calcium chloride, a dehydrating or a desiccating agent. Give reason. Desiccating reagents are those which absorb moisture from any substance. Desiccator is a bowl-like structure in which we put some calcium chloride like substances and put the substance which is used for dehydrating. Now, sulfuric acid acts as a dehydrating drying agent when it removes water from their substances for drying gases. Concentrated sulfuric acid acts as also dehydrating agent when it removes chemically combined water from any compound and due to its strong affinity for water. For example, when alcohol is treated with concentrated sulfuric acid, it removes water from it and ethene gas, which is commonly also known as ethylene, is formed. Concentrated sulfuric acid has removed H2O from ethanol and changed ethene. Fused calcium chloride is desiccating agent as it is drying the substances. You can see the example of desiccator here. I was talking about a bowl like structure. So this is the desiccator. In this part we put some calcium chloride and on that in any glass watch glass we put the substance that is dehydrated where in some time. It will take 12 hours or 24 hours. It depends on time. So this is the desiccator. Next question is question number 19. Give a reason why metals are arranged in series. Activity series of metals. Name a metal which reacts with cold water, boiled water and steam to liberate hydrogen in each case. Beta, as I have already explained you, reactivity series. Here are reactivity series is the arrangement of different metals in their reactivity series. In their reactivity series, these metals are arranged in decreasing order of their reactivity, and very few elements are in your book. On top in your book, that is sodium. I will share separately reactivity series also. So the metals which can react with cold water are sodium or potassium. Sodium and potassium, which are very reactive. The metals which react with boiling water like magnesium, aluminium, etc. And when steam, they are iron, zinc, etc. Next question is question number 20. Differentiate between hard and soft water, temporary and permanent hardness. Hard water with suitable examples. So here we will discuss. Yes, so hard water, it does not form lather with soap and soap is wasted, and soft water can easily form lather with soap. So, temporary hardness is due to bicarbonates of calcium and magnesium and it can be removed by simple boiling, while permanent hardness is due to sulfates and chlorides of calcium and magnesium. It cannot be removed by simple boiling. We have different methods for removal of permanent hardness like soda lime process, ion exchange process or zeolite process. Here are question number 21. Give balanced equation for temporary hardness enters into water. Temporary hardness in water can be removed by boiling. Permanent hardness can be removed by adding washing soda. So let's discuss here answers of all these questions. First we will discuss temporary hardness is come from where in water. It is coming from rainwater, because when rainwater falls on earth, CO2 dissolve with that and react with and combine with calcium carbonate as well as magnesite, which is magnesium carbonate, and forming a layer of bicarbonate which is soluble in water. These bicarbonates, this is the formation of bicarbonate, calcium carbonate plus water, CO2 gives bicarbonate. Calcium bicarbonate को बेटा अब you have to use small bracket, not large one bracket like that. Okay, and magnesium carbonate plus water plus carbon dioxide forming magnesium bicarbonate. It can be removed by simple boiling because it dissociate further in calcium bicarbonate and CO2 and H2. Same as magnesium carbonate on boiling form magnesium carbonate, carbon dioxide and water. Magnesium carbonate and calcium carbonate are insoluble in water, which can be separated out by filtration method. Next one is removal of permanent hardness in water by adding washing soda. Washing soda, as I told you, is sodium carbonate. When sodium carbonate added with water which contains calcium chloride or calcium sulfate, it forms calcium carbonate and sodium sulfate, same as sodium chloride and calcium carbonate. Calcium carbonate is forming insoluble precipitate which can be separated out by filtration method, and soft water get in separate container. Here are 21 questions of the exercise, which are the long question as well as short question. In next part we will discuss other exercise based objective type questions. So